So we've got three systems of equations in the variables x, y, and z. They do represent three planes in R3. The third one does have that 0 at the end, so it will go through the origin. The other two do have constants of 1 and 2. So they will not go through the origin, because if we plug in x, y, z, 0, 0, 0, we don't get the left side being equal to the right. So we're going to just kind of investigate what's going to go on here. As always, we're going to treat this like a run-of-the-mill system of equations, put it in a matrix and solve. So I have 2, 1, 5, 3, negative 1, 5, and negative 2, 2, negative 2, and 1, 2, 0. And just go ahead and do my row operations. I'm going to use this 1 here to get rid of the 2 and the 5. So I'll get 0. 3 minus 2 of negative 1 is 5. Negative 2 minus 4 is negative 6. And 1 minus 4 is negative 3. Now keep this one intact. And then minus 5 of row 2 here. And so I'm going to get 5 minus negative 5 is 10. And negative 2 minus 10 is actually going to be negative 12. And that's going to be 0 minus 5 of 2, so negative 10. And what we can see here actually now is row 1 and row 3. The coefficients for the y and z are multiples of each other, but we don't get the same multiple for the constant. So if I subtract 2 of row 1 from row 3, I'm going to get zeros on the bottom. And I'll get a negative 4 there. We don't like that. Doesn't really matter what goes on from this otherwise, but what we have is this kind of bad row on the bottom where we've got this 0 equals negative 4 statement, so there's no solutions. And so basically what we've got is 3 planes that actually are just not going to intersect in any meaningful way. So any 2 of the planes are going to intersect in a line basically, but all 3 of them are not going to necessarily intersect. So let's say I have this one, it's going to come out like this, maybe come out from behind like that. It's going to come intersect right about here. I'm trying to draw this as best as possible. So 2 planes are going to have this intersection line. Maybe I'll highlight that in red. So they're going to intersect here. But now I'm going to have this third plane, and it's basically the way it intersects these. The only way for this to work is if it does it sort of parallel. And that way, these things are just going to keep running in this little triangle pattern forever, basically. Don't necessarily expect everybody to be able to draw these. It is a little bit tricky. But maybe something like this, and then that's probably tucked away in behind. I think I'd maybe sort of hide a bit of this in there because I think the blue is going to come out over front. I'm trying to make this look 3D, but it's not the easiest thing. And so, yeah, like if I were to shade this up a bit, you can see I've got the green one here. And the blue is going to come out and be visible in here. We'll see it tucked under there. And then it's going to pop out there. And then we can see the pink kind of in behind there. So these lines are just going to go on forever and ever, and they're all going to run parallel to each other. So these are 3 planes can never intersect in the same place. And sort of some sort of illustration like this where they kind of intersect in this continuing triangle is really the only way that we can get this no solution case for the 3 of them. Unless another alternative might be that like 2 of them are full on parallel to each other. But if we actually look at the coefficients, we can see that like 2 of them won't be parallel to each other because they don't have corresponding coefficients. So like the default one other than that scenario is going to be these 3 sort of running in a triangle together. Any 2 of them will intersect in one place, but no 3 of them will intersect in the same place.